All right, we got more fun with trig functions. This is section 5.4. And I keep adding to my picture. Hopefully you noticed that. Originally, we had just started off with, in the unit circle, this triangle representing the y value, the x value, and the radius. And that's where we get sine and cosine. Then we expanded that recently to look at this triangle outside, where we take a perpendicular line from the x-axis and this point on the unit circle up and see where we intersect the radius. And when we do that, we end up with the secant and the tangent. So just a recap of what we got so far, that given an angle, this is right here, the cosine of theta, and this length over here is the sine of theta. If we extend the radius out a bit and see where it meets the perpendicular from the point 1, 0, we find that this vertical length here is the tangent of theta. So that's this green length, and tangent is useless without an angle. And then this extending that radius up to the point E gives me the secant of theta. And we just looked at that previously. So what I'm going to do next is I'm going to keep extending that radius out until I meet a line that comes perpendicular from the y-axis here from the point 0, 1. And if I do that, my claim is I get two new trig functions. And so I'm just going to take that triangle right there and redraw it down here. So it looks something like this there. And now notice theta is this angle down here. And if you think back to your geometry days in high school, if you have a pair of parallel lines and then you draw a line transecting through them there, this angle here is alternately interior to that angle right there. So these are alternate interior angles. Here, the red angle and the green angle there, alternate interior angles are congruent. So this angle up here must also be theta. So I'm going to draw that in my picture. So here is where that standard angle theta is on this big red triangle. This is my right angle. My claim that is this length up here is what I call the cotangent of theta. And that this diagonal length right here is what we call the cosecant of theta. All right, so COT represents cotangent. It's a partner to the tangent function. And this one right here is the cosecant. It is a partner to the secant function. Now, it turns out cotangent and cosecants are another kind of partners to each other. What's this length, this vertical length over there? If I look back at my picture, that would be this length. Oh, that's just a radius of the circle. So that has to be 1. So this is a 1 over there. All right. Next, we want to compare this big red triangle there to my green triangle here. And what I'm going to do with that green triangle to make it kind of look more like this one, I'm going to rotate. I'm going to pick this triangle up right here, this green one. Oops, that's not green. Let's highlight it. Green highlighter. I'm going to pick this triangle up right here. And I'm going to rotate it 180 degrees. And is that right? Yep, I'm going to rotate it 180 degrees. So if I rotate that thing 180 degrees, I'm going to redraw it over here. It's going to look like, please give me green, dear. There we go. It's going to look like this. And the angle theta over here got rotated, right? Zoom, that must be it's up here now. The cosine, again, I'm rotating this 180 degrees. It must be up here now. And the sine rotated 180 degrees. It's over here. And then here's my hypotenuse of 1. So I just picked this triangle up to make it look more like that one there. So they're in a similar position. So then I'm going to look at some arrangements of similar triangles. I played with before. Similar triangles. Similar triangles means if you take a ratio of two sides on one triangle, it has to have a similar ratio or an equal ratio on the other. So I think I'll look at the ratio of this horizontal component here. So horizontal to this vertical component there. And if I do that, on the big red triangle here, I get the horizontal is whatever the cotangent of the angle is, divided by 1. And on my green triangle, horizontal is cosine of the angle divided by the sine of the angle. And so what that tells me right there is this function I'm calling the cotangent, which is the length of that line extended in the unit circle. That cotangent is the cosine over the sine. And remember, the tangent is sine over cosine, right? So now that's its co-relationship to the tangent. Just flip it, okay? So that's the cotangent. And I'll summarize all the new trig functions in a moment. Next, I want to talk about this cosecant function. So to do that one there, let's switch colors to blue. I'm going to look at my hypotenuse here compared to the vertical leg. And on the big red triangle, the hypotenuse is whatever the cosecant measures out to be of a given angle. And the vertical is just 1. On my little triangle, the hypotenuse is 1. And the vertical component is the sine. So another new thing to know, the cosecant function is the reciprocal of the sine function. And remember, the secant was the flip of the cosine. So here is a summary of the things to know, the new trig functions. And I'm going to use the definition where we define them in terms of the sine and cosine first, and then we'll go refer back to a circle. So first we have the tangent. This is, in my opinion, the most important of the new trig functions. It is equal to the sine of theta divided by the cosine of theta. This is very important to memorize, exclamation point. The other ones are just, okay. We don't use those as much, but they are sometimes useful. Next one we talked about was the secant of theta, abbreviated SEC. So I guess I should write the real words here, tangent, secant. And we found the secant to be 1 over the cosine of theta. Just a moment ago, we found a function called the cotangent, which we will abbreviate as COT. And it's got to have an angle, otherwise it's pointless. And the cotangent was the reciprocal of the tangent. So there's 2 ways I can look at it. I could say it's cosine of theta over sine of theta, or I can say it's just 1 over the tangent. And now we have the last one, the cosecant. And the cosecant is abbreviated CSC, cosecant. And it's got to have an angle, and it turns out to be 1 over the sine of theta. So these are our new trig functions. Got to commit these relationships to memory. So in a class like this, where we have a lot of new definitions, new relationships, it's really a good idea to make yourself a glossary. So have a special piece of paper where there are special pages. So this is a special piece of information you want to have on that, like a reference page. And then another super important one you want to have are the, where did I put those? The special angles in quadrant 1, because if you know quadrant 1, then you can know all of the other quadrants just by flipping these points around the circle and rotating the angles. So that should go on your summary sheet, your glossary for this class. All right, new trig function. So I'm going to define them just in one more way with relationship to a circle. So if we know sine and cosine, then we know what the tangent should be, the secant should be, the cosecant should be, and the cotangent should be. All right, so given a circle, and we measure angles on a circle with this horizontal component heading out to the right here. So that's our reference for any standard, our reference line for any standard angle. And then from there, we measure some angle. And let's suppose our angle is over here this time. So this right here is the angle theta. Now, usually we have a coordinate system involved, so I'm going to draw in my y-axis here and my x-axis there. So then I have this point out here, and that point right there has an x value and a y value, and this circle has a radius. And let's suppose the radius may not be 1. So I'm just going to remind you about what the trig functions, how the relationship between a circle centered at the origin of some radius and the trig functions. So what we know is now that the sine of theta is equal to the y value over the radius. We know the cosine of theta is equal to the x value divided by the radius. We learned that the tangent of theta is sine over cosine. The r's divide out, it's y over x, or the cute version of it is the tangent turns the angle into the slope, which is kind of neat. Then we found the secant function, and we learned that the secant is the reciprocal of the cosine. So that means on the circle, it would be the ratio of r to x, because it's 1 over cosine. We just found the cotangent function, and we learned that that is either cosine over sine, or it's the flip of the tangent. I like the flip of the tangent because then we can just say, hey, it's x over y. And then cosecant, which we learned is the reciprocal of the sine. So instead of y over r, it should be r over y. So that means if I know information about one trig function, then it turns out I know information about all of them. So I'm going to do an example of that next.